The topic is bitwise operators. So remember this bit, I am saying bitwise. These operators are going to operate on the bits of integers. Okay, they are not directly working on the zeros and ones, binary values. They are not working on the binary values directly, but they are taking the integers and the integer equivalent to binary values. We are going to perform these operations. Okay, I'll explain in detail now. So first operator is bitwise AND operator, single AND. Earlier it was a logical AND. So logical AND means what? Double ampersand symbol. Now this is the operator I am going to use in C, and its meaning is what? Bitwise AND. So let's see one example, bitwise AND. Let us say 5 and 3. So now 5 and 3 are what? Integers I am taking. I am not taking bits directly. Rather I am taking integers, that you remember. 5 and 3 are the integers, and their binary equivalent, let us say, binary equivalent of 5 is 0, 4-bit, let us say 4-bit representation, depends on that. Number of bits, it could be 4 or 5 or 6 or 7, 8, 9, 12, anything depends on the requirement. Now for now I am taking 4-bit, assume it. So 4-bit representation for each integer. So this 5 is binary equivalent. I have already explained in the previous classes. You can refer them, how to convert an integer to binary. So 5 binary equivalent is 0, 1, 0, 1. 4-bit representation. The number of bits are 4 here. And 3 binary equivalent is 0, 0, 1. Now how is going to give you one bitwise operator I am saying. So whenever both are 1, both you can say here. So let me write it down for you. 0, 1, 0, 1 is 5. 0, 1, 0, 1 is 5. And 0, 0, 1 is 0, 0, 1, 1 is 3. And this is your 5 and this is your 3. Now when it is 1, when both are 1, AND operator will give you, this AND operator returns you. So both left hand side, right hand side, bitwise now. So both first one is 1, from the second also, out of 3 also is 1. That's the reason 1 last bit is the LSB bit, we call it as LSB bit is 1 here. Now next, here only one is 0, another one is 1. That's why here also result last but one also 0. And here also one is 0, another one is 0, result also 0, and here is 0. That's why we have result 0, 0, 1. So next we have OR operator, that is a bitwise OR operator. Again take the same example, 5 and 3. So it's 5 equivalent is, now this its integer equivalent I am giving it is a earlier result. Integer equivalent, it is nothing but 1. Now in this case OR operator. Now let us see here. So OR operator, again 5 is, let us say 0, 1, 0, 1 is a 5 binary equivalent, and 0, 0, 1, is the binary equivalent for 3. Now when you perform OR operator here, so OR operator meaning is what? Either of the should be non-zero. OR operator, either of the 1. Either of the means not necessary both ones. So 1, 1 is there, you can get 1 here, and here also 1, 0 is there. Either first bit is 0, second bit 1, 1, and third case also 1, 0 is there. That's why it's 1. And here both are 0. That's the reason 0. Now binary decimal equivalent, that is the integer equivalent, is 7. Okay, 0, 1, 1 decimal equivalent or integer equivalent is 7. So next we have bitwise XOR. Bitwise XOR. Okay, it's a cap symbol. So I am going to use it. This was a OR symbol and this is the AND symbol, bitwise AND, and we have a cap symbol. Let's take this example 5, 3. So between 5 and 3, the bitwise XOR. So output will be like this. So let's take this example. Let me write it down for you here. 5 is 1, 0, 1 and 0, 1. This is the binary equivalent of 5, and as again 0, 0, 1 are the binary equivalent of 3. Now exclusive OR is what? When either of 1 is 1 only, result is 1, otherwise 0. Either of 1 means what? Either first two case should be 1 or second case should be 1, but not both. Similarly, if both are 0, also result is 0. If both are 1, also result is 0. That is the XOR meaning. Now here in this case, both are 1. Okay, both are 1. That's why it is 0. Here you can see either one is 0. So first one is 0 and second one is 1. That's why either one is 1 or either one is 0. That's the meaning, same meaning. So that's why we have 1 here. And here also second case also 1 here. And here both are 0. That's the reason it is 0. Now its equivalent value is here. Now what is the 1110 numeric equivalent, that is decimal equivalent, means it is 6. Now when I perform the 5 cap 3 operation, its result is going to get is 6. Right. Next is NOT operation, bitwise NOT, tilt symbol. This is a tilt symbol used for performing bitwise NOT operator. So it should be used like this. So tilt. So tilt is what? Whatever the bits that number is having, so that all the bits will be tilted, means what? Flipped. So for example, so 5 I am taking, 5 values 101. This is the 5. So when I perform tilt operation, it's going to give you, instead of 1 it is 0, instead of 0 it is 1, instead of 1 it is 0, instead of 0 it is 1. So you should remember one thing is, for this bitwise NOT operator in a C language, the result is depends on the chosen bit length. So for 3 bit, you have taken 4 bit or 6 bit or 8 bit or 16 bit, depends. So usually in C language, the compiler takes 6 bit representation or 32 bit representation. In modern day, it is only mostly 32 bit representation. So when 32 bit representation is there, the value usually, sometimes it may lead to the negative value because of the bit flitting. Not, I am saying, not bitwise NOT means what? Bitwise NOT means what? You have to flip all the values. If 0 is there, 1 it becomes. If 1 is there, 0 becomes. So in this 32 bit representation in C language, usually for displaying the numbers, compiler uses 2's complement. Okay, 2's complement, I'll tell you in a minute. So for shortcut to get a 2's complement is remember this formula. If x is 5, its 2's complement is x plus 1 minus. That means what? If I want to find out in C, let us say 2's complement of this 5 is 5 plus 1 and minus. So this is your x here. So 2 plus 1 minus is what? Minus 6. Means what? What I am trying to tell you is, whenever you perform the tilt operation on 5 in C language, the compiler will give you output minus 6. That you have to remember, because minus 6, it's a tilt in a 32 bit representation. The minus compiler uses a concept called 2's complementation to display the numbers, negative numbers. That's why it displays a minus 6 instead of 10. So actual meaning here is what? Bit flipping is what? Negating the bit. So instead of 0 it becomes 1, instead of 1 it becomes 0. That is the actual meaning. So while doing that, in C language it uses concept called 2's complement. Now output is what in C program? If you run this in a C program, output you are going to get is minus 6. That you have to remember very carefully. Next we have left shift. So left shift operator is 2 less than symbols. So let's take example here. 5 left shift by 1 means what? Take the binary equivalent of 5, shift the bit by 1 position. That's the meaning of it. Let's see how this works. So let us take here 0, 1, 0, that is a binary equivalent. So when I shift left, what is the meaning of it? So when I shift left, so this position, this bit 1 comes here, and this 0 comes here, and this 0 comes here, and whatever the position here, it will be empty. So this is rotated here. So as a result, what is happening? So first 1 is coming to first position. So as a result is like this, and 0 is coming to the second position. and next to 0 1 is coming to the, and whatever the 0 in left hand side, this is coming to the last position, MSB. This becomes the MSB beacon, LSB beacon. MSB becomes LSB, left shift. This is now right shift. So right shift is this greater than symbol, two greater than symbols. So when I say right shift, take the binary equivalent of 5 and shift the bits by position 1 and one position by to the right. That's the meaning of bit. Shift the bits by one position to the right. So let's see one example again here and take the same 5 here. So when I say right shifting is means what? So this bit will be shifted here, shifted to the right. So this is shifted to this position, 0 is shifted to one position and 1 is shifted to 0 position, and this 0 is shifted to one position. What does it means? So 1 is shifted, that's not there, LSB in the position of LSB, this is vacant now. So for this position 0 has come, 0 has come. Now for the second position 1 has come, and whatever the bits here, so now it was earlier 0 has come. Now this position you have to fill with 0, not 1. Earlier that 1 was shifted to the left, but now here it is, I am just shifting only 0. I am just filling that place in MSB position with 0. That you have to remember. Let's see example code for this. So again, your main program starts with program starts with main and ends with closing brace and return 0. Let me declare two variables, int a equal to 5 and b equal to 3. Here, as I already mentioned you, whenever there is a statement preceded by two forward slashes, this is called comment. So this comment usually compiler will not consider it as a instruction. Means what? It will just ignores it. This won't execute it. It is for only readability for the programmer. Right? Why I am making this readability? I know binary equivalent of 5 is nothing but 0, 1, 0, 1, 1, 0, 1 actually. So 4-bit representation I am calling 0, 1, 0, 1. Now 3 binary equivalent is what? 0, 0, 1, 1. Okay, this is the binary. For my understanding sake, I kept that comment. Now let me go through the next statement. So I am printing here bitwise operator. I have already mentioned you many times. So bitwise operators, this is enclosed in the double quotes, that will be printed as it is, and a new line causes the cursor to wait in the next line. And here I am performing the AND operation, bitwise AND, not double AND. Remember this difference. Double AND is a logical AND operation, and bitwise is it is performed on the integers. That's why %d are the integer, ab are the integers. So here a comes, and here the second position b comes. So whatever there in the within this double quotes, it will be printed in the output area. This is your output area, assume. So that is the 5 and 3 equal to will be printed as it is. Now in place of this third %d, the result of a ampersand b will be printed. Right. So similarly for OR operation, similarly for exclusive OR operation, and then we have NOT operation. This NOT I already mentioned you. So because of it is taking 32-bit representation, not just 4 bits. For demonstration, we are using only 4 in this example. But C compiler takes it as 32-bit. When it is representing with 32-bit representation, it uses a 2's complement for representing a negative number. So output you are going to get is -6 here. So next operation is left shift operation. You can see. So the %d means what? A. So A is left, that is 5. 5 is left shifted by 1, and the result I am storing is nothing but A left shift 1. And similarly, % right shift, that is A is right shifted by 1. So let's see this demo here, how this will be executed. You can see first variable A equal to 5 and B equal to 3. We know there is 1, 0, 1 and 0, 0, 1, 1. And the first statement is printed here, you can see. And cursor is waiting the new line. And next statement here you can see in place of 5, and as it is 3 is printed. So because of logical bitwise AND operation, we have 1 is the result. And next is 5 3, that is the next operation that we are going to get is 0 0 0 1 1. That's the reason 7 is printed. Next we have a tilt operation. This is very important. So for A tilting, when I said, I already told you 2's complement, that is going to give you 6. Now left shift it is. So left shift bit just now we have seen in the example. So this is going to give you 10, and for right shift it is again it is 2. That now we have seen in the example in the previous case. Exercise 4.2. So the question goes like this: a company assigns permission to employees using a bit mask system. So bit mask system is as follows. For read we have 4, so that is 1004 in binary, and for writing it is 2, that is 010 in binary. Execute is 1, that is 001 in binary. So this is the bit mask system. Means what? For reading, writing, executing, these are the permission. Read, write, execute are the permissions that are given to the employees when they are working in their working environment on a particular file or a database, whatever it is. Now this employee has a read and execute permissions combined. So now what is your task? Check if the employee has a write permission using the bitwise operator. If yes, print access is granted, otherwise access is denied. This you have to print it.